Okay. So, since we did not get to see each other on Thursday, which was yesterday, today for me, we are going to do this via video. Okay, so you have been given a paper. I thought I'd make your life a little easier because this is the tedious part, is just writing down all the information. So I gave you some of it in chart form. I spent most of my day doing this. And then we're going to fill it out. We're going to practice it, and we're going to do 2 sections today. We're going to start with 1.3, which is what this sheet is. And then we're going to do 1.4, which actually involves you taking some notes in regular paper like we normally do. Okay? So we're going to do both. If we don't finish this in class for whatever reason, something crazy happens, you never know with the weather and things, just finish them yourself at home. We will take our quiz on Monday, but we will have time to talk to each other before you take your quiz. Okay? So it will be okay. I promise. Okay? If you cannot see this, remember you have the sheet in front of you. This is as zoomed in as I could get so you can see the chart. Just listen to me and write while I'm writing, okay? Do your best. I know that this is not a normal thing. So, at the top, you have your goal. Our goal for this section is we're going to learn these properties, then we're going to identify them, and then we're going to practice them. That's what we're going to do. You already know all these properties. We're just putting crazy names with things you already know how to do, okay? So I broke them up in sections. The first properties are addition properties, okay? This first property is called the additive identity, which literally means when you add something to 0, what are you going to get back out? You're going to get that thing back out, right? We all know this. We learned in elementary school, right? So you're going to fill in an example. I'm going to give you one, right? So if I said 3 plus 0, hey, what's my answer going to be? We're all going to go say 3, Miss Rinaldi. Yeah, of course. That's correct, right? It's that easy. We know that, yes? I hope so. Okay. Next, additive inverse. Inverse is think about what's the opposite or the opposite of addition. What's the inverse of addition? Well, it's subtraction. So A plus negative A. So when you have a plus a negative A, something plus its inverse, you get 0. Both additive inverses both additive identity properties have 0 in them. Okay, then we have a real example, right? So if I have 3 plus negative 3 in parentheses, because it always has to have plus in it, that's why negative 3 is in parentheses. Again, that equals big old goose egg 0, right? Does that make sense? I hope that makes sense, because if it doesn't, I don't know where we're at this point in our lives. Okay? Now we're talking about the multiplication ones, and then we'll do some practice problems just on those, okay? So multiplication. First, it's called multiplicative. Okay, I'll say that again for you. Multiplicative. Multiplicative. I know it sounds weird. It's hard to say. I always abbreviate it mult and then whatever it is. Okay, so it's just like multiplication. So if you can't say it, it's okay. On your quiz and test you'll have, if you were given a problem like this, there would be a little square here and you would click it and you would have to choose which property it is. So you won't actually have to spell these, which is good for those of you or anyone, including me, right, who cannot spell well, which is why they made spell check when I typed this paper. Yes, okay? Now, multiplicative identity says anything times 1 equals that thing. Again, all true for all numbers, right? So if I said 4 times 1, hey, what's that equal? That's going to equal 4, duh, right? We know this. I'm sorry, I'm left-handed, I can't help. Maybe if I turn this sideways and turn this side at the same time, I will get a straight paper for you while it's crooked for me. Okay. Next, multiplication property, multiplicative, I call it multiplication. Multiplicative property of 0, it means anything that is multiplied by 0 is what? 0, right? Everyone is, hopefully somebody said it out loud, even though I can't hear you, right? That'd be funny. I know someone saying it. It's probably Superscript Boy over there. We all know, okay? Now, 5 times 0 does equal 0. We know that. Yes, we know it. It's in our brains. Elementary school, we spent all the time going, 1 times 9 is 1, right? It's not that exciting as it used to be anyway. Okay, last one. Multiplicative, I can't even say it anymore. Inverse. I wrote 2 different equations for you because The top one is with when there's already fractions involved. That one's usually the easier one. The bottom one is when there's whole numbers, and I'll show you what I mean. So an inverse of a fraction is to take whatever the fraction is. Our first one is a over b, and to flip it. The inverse of a fraction is its opposite. Its inverse is to flip it. Just that it. No sign change, just to flip the fraction. Anytime you multiply anything by itself, you get 1. The reason for that is because when you multiply fractions, how do you multiply them? Think about it. You do not cross multiply. Remember, you only cross multiply when equal signs in the middle. There's no equal sign in the middle. This little guy right there, that's a dot. That means multiplication, right? It's not a decimal. When you multiply straight across. So this top one up here really is doing AB. A times B is really AB. B times A is really B times A. So it's AB over BA. When you have the same thing on the top and the bottom, they cancel out. They divide to equal 1. A divided by A. A over A equals 1, hence this answer right here. Okay, let's do real numbers. Okay, so if I give you the number 2/5, what's its inverse? Someone said it in their heads or out loud. It's 5 over 2. When you multiply something by its inverse, you get 1. It's easy when it looks like that. Now you have to think about it. What about the whole number 8? What do you multiply it by? It gives you the answer 1. So it'd be like 8 times x equals 1. You figure what x is. What would you multiply it by? Think about it. 8, just like over here, 8 is really 8 over 1. It's a whole number, right? Whole numbers are saying I have 8 people in one room. That's why 8 over 1. So flip it, it's 1 over 8. That's how you multiply them and get the answer 1, okay? Now, we have these up here. You can look at them if you want for now. On a quiz or test, are we going to have these charts? No, ma'am. No, sir, we are not. I know I'm mean and evil sometimes about it, but we don't record this stuff in our noggins. If we don't learn it, we're not going to know it. And the state test doesn't give you all this fun stuff either, okay? So, examples. There's 5 of them there. You just learned 5 properties. Look at each of them. It says, state the value of x. So first, look at every single one of these and go, what would make this true? What plus 0 makes 3? And then just write the number, right? X equals, and then write the answer for every single one. Okay? Then, next to it, write what property you used out of those 5 we just talked about. Okay? So the first one, x would be 3. Okay? Now, addition, we got ourselves back. Addition, ourselves back. Think about it. What property is that? Normally someone would say it out loud or I would hoax it out of you. It is the additive I'm spelling wrong. Identity. Ooh, I spelled that time wrong. Okay, it's okay. Whew, man, it's been a long day, I can tell. Okay. Next one. Oh, technically, the next one is this way, isn't it? Okay. Next one. 4 times what would give me 0? So this is multiplication. So my answer is mult something, right? Multiplicative. I'm just going to abbreviate mult. Okay. 4 times what would give me 0? What's the only thing I can multiply 4 by? What would x be for x to be 0? That to be 0. X would have to be 0. Okay, what property says when I use multiplication and I use the number 0 when I multiply? It is the multiplication property of 0. Exactly what it does is what its name is. Sometimes they really are that easy. All right, try the last 3. I'm going to actually literally freeze this even though I will still be recording. Try the last 3. See if you get them. I'll write my answers also. Okay, and then we'll go through them. Hold on. Okay, we're still working. I'm still writing, so I hope you're still writing. Mostly it's just because I'm trying not to spell wrong this time. Okay. Okay, I am actually done now. Okay, are we almost ready? Too bad you're not here today. Or I'm not there today, whichever one you really mean. I'm here on Thursday, you're there on Friday. We're just not there on the same days. I'm eating myself a peppermint right now. Okay, let's see if, okay, now it's just crookedness is driving me crazy. You've got the same answers I do. Move this mouse because it's in the middle. Okay. We did 1 and 2. 3, I got x equals 1/3. Did you get x 1/3? And I got multiplication inverse, multiplicative inverse. Okay? Next, number 4, we're to the right. I got x equals -4. And since we're using addition, that's the additive inverse. And then number 5, I have x equals 1 because 2 times 1 equals 2. And that would give me the multiplicative identity. How did you do? Did we do good? Hopefully we at least got all the x's right. I'm hoping we all got it all right, but it's okay if we didn't. We just have to practice it, okay? Okay. Last chart, last slide, okay? Let's talk about it. So reflexive. The format is a plus b equals a plus b. How I remember reflexive. Reflexive sounds like the word reflection, reflect, or you see where I'm getting from there, okay? So I always remember when I look in the mirror, I see myself exactly the same. You see how the left side is exactly equal to the left side. It's like exactly the same on the left side and the right side, the equal sign. That's how I remember. Reflexive means exactly on the same both sides. Okay? So any example you want. If you want one like what we just did up here, that would be like this. Okay? 3 plus x equals 3 plus 5. That's an example, just kind of like the problems we just did. Then you go, hey, x equals 5. This is reflexive property, okay? 3's are in the same spot. The x is in the same spot as 5, and that's how we realize or identify that x is 5, okay? Okay. Next. Symmetric. This says a equals b plus c. Then, so the new answer, b plus c equals a. So what's the difference between the first equation and the second equation? The order changes, right? A was on the left, now it's on the right. B plus C in that order was on the right side, now it's on the left. We see how the order is exactly the same? That's the point of symmetric, okay? So the sides switch, but the order is the same. That's the weird part, okay? Example. Yes? How about 8 equals 2 plus 6 and 2 plus x equals 8. There you go, put your x on the second time. Does that make sense? Are you seeing it? Okay. Now, granted, they can put x literally almost anywhere, so that's the only tricky part. Okay. Next, commutative. That one's hard to say, especially if you have mint in your mouth, okay? A plus B equals B plus A. So commutative is kind of like taking symmetric and reflexive and mixing them together if they had their own child. Because reflexive, left equals right. Symmetric, they switch the sides. So this one they switched them, the order changed, right? So it's the same two things, the order just flipped. Community. I think the community, you're in the same community, but it doesn't matter what way I say it. Say like, John and I lived in Racine, or myself and John live in Racine, right? No matter which way I say it, I don't know who John is. It doesn't, the order doesn't matter because we both live in the same community, okay? Whatever helps you make sense of them, as long as they're school appropriate, and if they aren't, don't tell me, okay? So, example with x in it. How about 8 plus x equals 5 plus 8? Remember, they switched their order. Okay? Associative. Before you even look at it, see how it says A, B, C on both sides equal sign? A, B's, and the C's are in the same order. The only difference is what? Where the parentheses are. And on the left side, the parentheses are around the A and the B. Those guys are going to go together first. But on the right side, oh no, B and C are going to go together first. The funny thing is, in addition, right? Addition, the order doesn't matter. We all know this, which is why it's called associative. How I remember it is who they associate with. So this group, I'm going to associate with you today. B says, I'm going to hang out with Kelly. The other day, be like, nope. B's like, no, I'm going to hang out with Kristen today, right? It's just saying who they're grouped with. They're all together in the same order. Who's grouped with who? All right? So, example. I'm going to have parentheses. 3 plus x parentheses plus 7 equals 3 plus parentheses 5 plus 7. Close your parentheses. Again, first-hand example of where the x goes and how it works and how the property is used. The last one, we just used this in our last notes. It's the one you know the most, though sometimes we don't remember this word. Substitution, right? All substitution means is you had an equation, a times b equals, and instead of writing a again, you substitute in your number, which is why I put a little hashtag sign there, to multiply times b. That's all that means. What we already know, right? And it'll look just as simple as this. 4n equals 4 times 11. Only difference is this n, it turned into an 11. Now these guys, this part is usually easy, this top part, okay? This bottom part causes some, I don't know, tension with people because of the operations. Most of these operations are addition, which makes you think about these. Remember, zoom out. Addition properties all have the number 0 in them. So they're actually an additive property. They have the number 0 in them. Multiplicative or multiplication properties have ones and zeros in them. Always, one of the two. The properties that are special, that work all the time, any other ways with all kinds of numbers, most of them are most of them are addition other than substitution, right? And none of them will ever use 1 or 0, okay? That's a big hint to kind of like separate the kinds of problems you have to what kind of properties they can be. Maybe if you're going to like prioritize them, or I don't know, compartmentalize them in your head to figure out which one's which, okay? Which brings us to the back of this page, everybody. I'm kind of seeing my marker through the thing. Okay, so there's 10 of these. There's 10 of the properties, okay? So you just go through and go, okay, multiplication. Now again, it says state the value of the variable. So x, right? I think oh no, that's an n. That's why it says variable. And state the property used. If you want, it's 100% okay. Go through first and just say what the number is. You don't even have to write x equals. You just have to write, okay, that number, 7 times what? Okay, well, that has to be 1, comma. figure out what all these numbers are, put a comma after them, then figure out the properties. Because if they use the number 1 or 0, they are a specific kind of multiplication or addition property. If not, they are one or the other 5 properties. That helps you break down your information. Okay? Does that make sense? I'm going to pause this, let you work. I'm going to write them all down in the answers. You work. You may not finish it, okay? But I'll show it to you. You can try it again later because we still have another section to do. It's not that hard though. But I'm going to let you try it, okay? And you can flip back and forth and back and forth. It's okay. Try it out. Maybe try it without looking, but it's okay if you have to. Okay, I'm working now. I'm going to go through and do all my X's first, or N's, because some of them are N. I'm still working. I just finished all my numbers. I'm writing words down now. I'm going through my non-normal ones, so reflexive, substitution, commutative, associative, things like that. I'm doing those first. I lied. I just started at the bottom. It just didn't work well for me. Doing good, doing good. I got one wrong. I was trying to go too fast. I thought we used pencil. Well, if you guys use pencil, I did not use pencil. There we go. I only have one more left. Okay. Let's see, make sure I'm zoomed out all the way. Ready or not. Here I come. question is, can you see it? Can I zoom in? Ooh, that's as zoomed in as I can be. Okay. Well, I couldn't touch it. I'm running into it with my body. Okay. I really did use every property. I didn't double up on anything. I'm pretty impressed because I just made those questions up. Remember to always double check. I always mess up the property of 01. I think too fast sometimes, which happens, right? We always double check. That's why, and I watched you guys do it even on your pretest. That's why we should sometimes double check our work, especially with things like this, right? When it's mental math, that's why we have a calculator. That's double checking your work. But any other time, when it's like this, maybe we'll double check, make sure you're writing down the right thing, right? Because you move too fast. We all do it. Okay? Make sure you're looking at this. Make sure you check your work. You can always try these later if you didn't finish them. Okay? You can always ask the sub if you didn't get to finish them, you want to do them later. I am going to move on to the other section so we make sure we cover them both. Okay, remember, you do have a test, a quiz on Monday. Your test for the chapter is going to be next Friday. It was supposed to be Thursday, so it's moved back a day to Friday. So it doesn't change things a whole lot. We do review before test too, so that's the good thing. So Thursday next week will be review. Okay, and we can't forget these because these will be on our test. This will be on our state test too, so we can't forget any of it. Okay, but now we have to use the whiteboards again to go back to the next section. I'm trying to give you as much time as possible looking at this. Okay, I am going to take it away now. Okay, zoom back out. Move that paper. I will leave it here on my desk, just in case. There you go. Okay, get a marker. Okay, this section in comparison is much easier than the last one. There's actually some math in it, and there's no memorizing all the craziness of the words, okay? We do have some vocabulary to do, but much easier. Okay, so let's start with the new section. You do need a piece of paper, like I said before. This is 1.4. The title is the distributive property. Okay, we're just going to get all the words all at once. We're not going to back and forth. We're just going to do it all at once. Save ourselves some time. Okay, if that sounds like a good thing to you. Okay, first thing we need to talk about what it means to distribute, right? First, what operation does it mean when we say distribute? Yes, it means multiplication. Right? When you multiply, you're multiplying numbers by numbers. If you have just the variable x, what number is in front of that? It's the number 1, right? Yes. Okay. So if we're distributing, we still have something to multiply by. If we multiply numbers, right? If I have x times 7, can you actually multiply those two numbers together? Right? 1x and 7, those are two terms technically right now. Can you multiply them? Yes, you can, because it's multiplication. Terms, we talked about this, it's yesterday to me, but it's 2 days ago. The last time we took notes. A term is numbers and variables held together by multiplication. So technically, this is one big term, so they can be multiplied. So you take the 1 and the 7 and legitimately multiply them, right? And you get 7. Since there's still an x there, that's an x. So terms, multiplication holds things together, so they are allowed to be combined. Now, things, when there's addition, those cannot be combined unless they have specific things. That's why we talk about combining like terms. If I was there, I'd be like, who knows what this definition is? And sadly, I cannot ask you, and I can, but I'm not going to hear your response, right? When we combine like terms, our goal is, or what we need, I had hiccups. What we need to do is we have to have the same exact variables and the same amount of each variable in both terms. So both terms we want to add together, they have to have the same exact variable and the same amount of those variables, right? So for example, right, we cannot add 3x and 3x squared together because this only has 1x and this has 2. Yes, the variables are the same, but their powers are not. Since their powers are not the same, they cannot be added and you just leave them alone, right? Okay. Another definition, simplest form. What this means, right, is we have no leftover parentheses. You should never have parentheses left over. That's why we're talking about distributing, because we should be doing that thing. Also, no more like terms. Because if not, why would we be talking about distributing and combining like terms if we haven't done those things? Right? That would make sense to me. There is one more word. I'm just going to slide this way. The word is coefficient. A coefficient, as an example, 3x. This has a coefficient. The number is 3. So now think about it. Can you describe this now? This is hard to do. Can you describe what a coefficient is? What is 3 in this instance? 3 is a number. Yeah, we know that. Someone was going to say it, I know. But what is 3 in this instance? How do you just define a coefficient? It is the numerical, almost said that, value in a term that represents a factor. Right, a factor, but in this sense anyway, right? A factor is something we can break down, right? And this one, technically, the only thing that makes 3 is 3 times 1. But what this means, it has to be this whole number, but not just, you can't say whole numbers because a fraction is also a coefficient. The point we say factor is because if we just put a little squared on that too, no, that's ugly. But the point is that 2, since it's in the superscript or the power or the exponent position, they're all the same thing, right? That is not a term. It's not a part of the term. It's a part of the variable, which is in the term, but it's not a factor. And only factor numbers can be coefficients. That's why they use that word, not because we can actually factor a 3, because technically we really can't do anything with 3. 3 is just 3. It's a sad little prime number. Doesn't have really any friends, right? So he's just who he is. Okay. So that's what we got. Does that make sense? Before we move on, those are all your definitions. Now we're just gonna do what we do. Okay, and I'm gonna move this top board. Okie dokie. Now let's talk about the basics. After I erase this board, before I get red all over everything I have. Okay. Okay, example. We're just going to mix our stuff together, okay? So, distributing. Let's talk about it. Basic form. 2 parentheses. 4 plus x, close your parentheses. When we distribute, we said we do what? We use the operation multiplication, right? We multiply and distribute by every number and term that's in there. By every term, we only multiply the number. So the x there only has the number 1 on it. Yes. So we do 2 times 4, give me 8. We do 2 times 1x. They're both positive. We have the addition sign. We keep it 2x. Then we would go, are there any like terms here? Do 8 and 2x have anything in common? No, because this has an x and this does not. This has the coefficient 2. This is not a coefficient. Do you remember what a number's called when it does not have any variables with it? It's just a lonely thing. About 1 is the loneliest number, right? What is this called? Does anyone remember? I hope someone remembers. It is called a constant. That's any number without a variable is called a constant, okay? So since this is a constant and that is a term with an x in it, they have nothing in common. And which means it's in simplest form because we got rid of the parentheses. Easiest form. Now, can we just still distribute when something looks like this? Make it a little more different. 5x squared in parentheses plus 2x minus 3, close parentheses, and then 7 in the back. That's an ugly 7, by the way. That's fine. Fix it. Times 7. That 7 right next to that parentheses, does that still mean multiplication? Yes. So does that still mean we can distribute? Can we distribute even if it's in the back? Though this was in the front? This still means multiplication next to a parentheses. This still means multiplication. So though the location is different, is the operation or what it's asking us to do any different? It is not. So we're still going to distribute. It just feels wrong because every time they've given you this problem, they always put it in front. And then you get so comfortable and warm in that spot, and then they pull the rug right from under you, and then they change things just to scare you. When it's not that scary. It's just in a different spot. He just is in the back of the line. 7, he's the biggest number. We'll put him in the back. That's all. So you still multiply him. So you do, 7 and 5. Okay, that's 35x squared. Keep the x squareds. 7 and 2. Okay, that's still positive. That's 14x. Okay, that's negative. So 7 and 3, that's 21. Do these have any like terms? We're done with the parentheses. We're good. Are these like terms? They both have x's, but are they the same amount of x's? No, ma'am. What about these? Are these like terms? Nope. These guys? Well, if these guys weren't, these guys are not going to be, right? So, no. So is this in simplest form? Yes. Cool. Awesome. Great. Yes, Miss Rinaldi, we're wonderful. Okay. So far, all we've had to do is distribute. Now let's mash them together. Okay. Let's do it. Let me find one I like. Oh, bring this down. Ready? Parentheses. 5m plus 2m parentheses times 10 plus m squared. Now it is legitimately up to you how you choose to do this. When you see parentheses, your first instinct is go distribute, 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 distribute. It is literally up to you. Since there are a bunch of variables everywhere, you could just distribute right away, get rid of your parentheses, then deal with your like terms. Or you could go back to your basic knowledge and go, we just talked about order of operations, PEMDAS. Please excuse my dear Aunt Sally. We could do that first, which in the end will also help us. It does not matter which way we do it. It'll get the same answer. 100% promise you. That's the beauty of math. You will get the same answer no matter which way you do it. Okay? So, let's do it both ways, right? Let's distribute. Distribute. We get 10m plus 20. Why did I write 10m? God bless America. 50m plus 20m plus m squared. So I distributed. Then you go, Can we combine any like terms? That just has an M. Oh, that just has an M. So we can add their numbers together. That is 70M. This guy, sad, lonely, squared guy, he's alone. So we bring him down so he's not actually lonely. That's our answer. It took 2 steps, right? Okay. Let's try it the other way. I'm just going to erase those lines. Order of operations, yeah? Tells us to do the inside of the parentheses first. You right? Okay. Or inside the parentheses. This is inside parentheses. 5m plus 2m. You look at it and go, can I add those two things together? Why, yes, ma'am. You can. So 5m plus 2m is 7m. It says times 10, so I'm going to write times 10. And I'm going to write what's left over, m plus m squared. Then the rest of your operation says exponents. Well, this exponent's with an m, so I can't do anything there. My dear, multiplication, division. Oh, I see multiplication. Multiply your whole numbers because multiplication really shows terms. 7 times 10 is 70m. I use that. This is left hand alone. Bring him down so he's not lonely. And other than the fact that that was written very ugly, same amount of steps, same amount of work, same answer. Does that make sense? So does it really matter? No. If you're better at one way than the other, could it make a difference? Potentially. Maybe. Possibly. We'll see. Who knows? Let's try some things. I just marked on the thingy. Okay. How about... I had one. Where is it? Ooh. Let's try the one I really liked. Let's try this guy. It is 4y cubed plus 2y minus 3y plus 8. What do you do here? Actually, an easy one. So easy, it might be too difficult. It's not. I hope not anyway. If it's difficult, we got a problem, right? We're having issues, we got a problem. Oh, there it is, yeah. Oh, that's close on the numbers. All right. Is there any parentheses? No? Okay. Multiplication, division, no. Addition, subtraction. So when you're just combining like terms, I always work left to right and go, this guy, he's got a cube. Anybody else got a cube? Nope. Bring him down. He's lonely. Okay. Next one, this guy, you can cross him off if you're done, has just a y. Ooh, this guy has just a y. Add them together because eventually, and I'm not lying to you when I say this, these things will have like 10 terms in them, and sometimes it gets overwhelming, which is why the cross-off box method is helpful, okay? Positive 2y's minus 3y's, well, that's minus y. Can I put minus 1y if I want? Yeah, sure, Mr. Naughty can. Do I have to? No, ma'am. Okay. Then this 8. So you have anybody add 2? Nope. He's a constant, right? Yep, he's lonely. Bring him down too, so he won't be lonely anymore. Then you double check. Any parentheses? No. Any like terms? No. So is he in simplest form? Yes. Perfect. Done. If you were to get a problem like this, b squared plus 13b plus 13. This is your new problem. It's on the bottom. And it says simplify each expression. If not, write simplified. Simplify each expression. Was there any distributing? Heck nah. Okay. Is there any like terms? That has a b squared. This has a b. Anything in common? No. So if they have nothing in common, you get the lovely option to just write simplified. And be like, hey, you know what? My dude, I'm done. Finished. Whatever. This is it. It was that easy. Okay? Sometimes they really are that easy. Sometimes they're not. Right? For example, oh no, I fell asleep again. I hope I didn't fall asleep on you. Okay. Last one, I'm thinking 7 parentheses. A squared plus B. Close your parentheses. Minus 4 parentheses. Oh yeah. A squared plus B. Close your parentheses. So, take a. What's the difference here? Well, there's 2 sets of parentheses, Miss Rinaldi. Oh, okay. So, does that change anything really? It just means you have more work to do, right? Okay. So, start here. Okay, left to right. Let's distribute. Again, if there's no number in front, it's just a 1. If you really have to do it, put a 1 in front of them. Okay? And that kind of looks like a B now, but it's okay. 7 times 1 is still 7. Keep the variables. 7 times 1, it's positive. Keep the variables. Easy. Now come over here. This 4. Got a real question for you. Is it just 4 or is this 4 negative 4? Think about it. If this were here and there was no parentheses, you'd say this is minus 4. So why do we take it with it? Because this is distributing. You have to take this everything because there's a whole group behind it. If this was just one number, it'd be fine. But because you're distributing, everything needs to be affected by this negative. So all of this has to go with you. People make this mistake every day. So negative 4a squared, because again, we're just multiplying by 1, negative 4b. Now we got 4 terms. We started this big guy. We're a little smaller. We're not done. Start from left to right because I got parentheses. I have an a squared. Oh, right here is another a squared. 7a squareds minus 4a squareds gives me 3a squareds because the variables do not change. Only the coefficients do. Then we do it again. Oh, there's a b. Oh, there's another b. 7 minus 4 again is positive 3. They both had a b, so we hold on to b. We don't now have 2 b's, we have 1 b. Now look, we started this big ugly guy with some parentheses and some crazy madness. We ended with this pretty guy with only 2 terms. One addition sign. And it's all positive. How nice is that? Right? It's not hard. You just got to pay attention. Right? This should be like the easiest thing we've done all year, which is not saying a lot because really, we haven't done anything really hard other than 1.3 maybe, depending on how you feel about memorizing all that information. Okay? Practice this information. The book has a practice test after 1.4 in there. It's on page, I'll tell you what's on page. I'll tell you. Give me just a second. In your book, I'm pretty sure it is on page 32. Yeah, I'm pretty sure. It's on page 32 in your book. There is a practice quiz in there. Now, they do not have 1.3 the way I like it, but if not, just go back through your homework. It is really not that bad. It's got more in it than it needs, but honestly, the practice quiz 1 through 10, great idea. Also, 18 through 23, a great idea. And then practice the words. You will be fine. You will be wonderful, great, magical, okay? And I will see you on Monday. Email me if you have any questions. Obviously, it's the weekend, but I will be around because, just me and my dog live my life. So just let me know, okay? Have a good weekend.